Hello, game theorists. Today we are looking at the public goods extra credit game. Let me just remind you of the rules. So, if you chose to participate, I put you in a random group of 5 students, so 4 others and yourself. And what happens is going to depend upon how many tokens you contribute and also how many the other people in your group contribute. Everyone began with 10 tokens, as you can see here in the directions. Each one is worth 0.1% to your grade. And with those 10 tokens, you have to decide how many do you want to keep and how many do you want to contribute. Now recall from micro that a public good is one that is both non-excludable and non-rival. So if you contribute to this thing, then those contributions are non-rival. It raises your grade and also everyone else's grade in the group. And it's also non-excludable. You can't prevent people in your group from benefiting from your contributions. It's just like other examples of public goods like fireworks. If you set off fireworks in your backyard to celebrate the 4th of July, you can't prevent anyone else from enjoying your fireworks, and you also are not harmed by them watching your fireworks. There's no rivalry there. So this game models contributions to public goods like fireworks. So the payoff is how many tokens you keep out of those 10 plus twice the average contribution to your group. So let's analyze our game. Now, if you only care about how many tokens you get at the end, then the Nash Equilibrium would be nobody contributes. You all keep all 10 of your 10 tokens. Here's how I can verify that. If you contribute one extra token to the group, that means your tokens kept go down by 1. Because there are 5 people in your group, one extra contribution will raise the average by 1/5. But you don't get the average, you get twice the average, so that means that this will go up in total by 2/5. So if you contribute a token, you lose 1 over here, but you only gain back 2/5. Overall, that's going to cost you more than it's worth. Overall, it brings your payoff down. So you want to contribute as little as possible, which means that everyone contributes 0. Now the cooperative outcome would be everyone contributes all 10 tokens. In that case, the average would be 10, and then twice the average is 20, so you can see that's definitely twice as good. It's better than everyone playing the Nash Equilibrium. It can be rational to contribute if you value cooperation for its own sake. It's not rational from this point of view of just trying to maximize tokens, but if you care about cooperation, and you care about cooperation more than you care about tokens, then it could make sense. So once again, as with many of our class games, there's a tension between cooperation and maximizing tokens. So that's the theory. Let's see, what did you guys actually do? So let me pull up that spreadsheet. So here it's all anonymized, so I listed the results by your B number, and this spreadsheet will be up on Blackboard. So here are your contributions. I create a random variable to assign you guys to groups. So the average contribution, if you look at all these results here, was around 3 or 4, but there was substantial variation across groups. Like this group 2 over here contributed very, very little. Average there was only around 0.6, but group 7 here contributed on average 7.6. we had 2 people contribute 10 and 2 people contribute 8. So overall, very high contributions and very high payoffs for that group. So I create a histogram to show the distribution of contributions. The most common choice was our Nash Equilibrium of contribute 0, but several of you guys contribute a little bit more than that, and a couple of you went for the cooperative outcome where you contribute all 10. Now I've had my classes play this game before. However, those classes were face-to-face rather than online, and also I changed the timing a bit of the public goods game. Typically, I have my students play it earlier in the semester, and I noticed that playing games earlier rather than later seems to affect things. However, here, I compare you guys to what happened last spring. I just pull that up, and the histogram actually looks pretty similar. So it looks like in this particular game, switching from online and switching to playing the game later rather than earlier didn't really do a whole lot. If you've been following this series, I had this narrative going earlier where the online class was more impersonal and thus less likely to cooperate. But here, cooperation seems fairly similar. Notice in the last game we played, cooperation was also pretty similar. So that narrative about online classes being less cooperative seems to have broken down. I'd be curious to see what happens in our later games. So that's all I have for today. Be sure to stay safe out there.